This question, a smooth semicircular wire track of radius r is fixed in a vertical plane. One end of a massless spring of natural length 3r/4 is attached to the lowest point O of the wire track. A small ring of mass m which can slide on the track is attached to the other end of the spring. The ring is stationary at P points as the spring makes a 60-degree angle, which is shown. The spring constant is mg by consistency when the ring is released. Okay. Draw the free body diagram of the ring. So that is quite easy to draw the free body diagram. So here we have the circle. This is the point O. This is the center. So this is the point P, and there's the spring. So here what the forces acting on this point P are like that the mass has m, this has mass, okay, so there's mg, and because of the spring is stretched here, okay, so there will be a force acting in this direction, the spring force, and there's a normal acting in this direction. So that's it. So this is the FBD of this P point. The forces those are acting on at P point. Okay. So now we'll try to find out that spring force acting at that point. So for that, let's draw the diagram again. So that's a semicircle. There's a point O. There's a point P. Okay. And there's a spring here, which is held stationary. The P is the ring basically. Okay, so now this angle is 60. Okay, and if this is the center, so this CP is nothing but radius of the circle. This CO is again R, and if this angle is 60, so this angle is also 60, right? Right. So this angle is 60. So obviously this angle is also 60, which means this length is R. This length of the spring is R. Okay, now in the question it said that the natural length of the spring is 3r/4, right? So which means that the spring is stretched by r/4 distance. So that's why the force is acting in this direction, right? Okay, now the spring force basically at this instant is equal to kx. Okay, so k into r/4. K is given as mg/r, so which is basically mg/4. Now there is a spring force acting at this instant. Okay, now we need to calculate the tangential acceleration and of the ring and the normal reaction. Okay, so first we'll calculate normal because here that P is stationary. So for that we have this FBD. So we'll try to find out the forces. Okay, so this is normal here. Okay, so I'll draw that again. So this is normal. This is mg. And there's a spring force, right, which is acting in this direction. Now I'm going to take the components along normal. Okay, so here this angle is 60, this is 90, so this is 30. Okay, this is 30, and sorry, the total is 60, right? Total is 60. So the component of spring force towards normal. Okay, so that will be FSP cos 60. And if I take component of mg in this direction along normal, so this angle is 30 again because this is 30. So this is 60. So the component of mg is also cos 60, right? So this angle is 60 again. The component of mg in this direction is cos 60. So I'm just writing here. So FSP, which is acting in this direction, right, towards normal. So FSP plus n, because these two forces are acting in the same direction. And that should be balanced by mg cos 60. Now from here the n is equal to mg cos 60, which is by 2, minus FSP, which is mg/4. So mg/4 cos 60, which is again 1/2. So from here we are having that normal, and that is mg/8. So that is the normal. Okay. Sorry. One mistake, one mistake, 3 mg/8, sorry, my mistake. So normal is 3 mg/8, right? Okay, now normal is done. So now we'll calculate the tangential acceleration. For that we need to take components of forces tangential, right? So it's kind of simple now. The net force, tangential force is equal to, there are two forces only, okay. So, and these components are like basically FSP, the spring force sine 60, plus mg sine 60. Okay, so only this component is left. The Ft is equal to, FSP is mg by 4 sine 60. So mg by 4 plus, so I'm just taking the sine 60 common, mg into root 3 by 2. Okay, so here we are getting like 5 mg by 4 into root 3 by 2. So 5 mg into root 3 by 8. So that is the tangential force, and tangential acceleration will be divided by mass. So this mass will be cancelled. So acceleration, tangential acceleration equal to 5, sorry, it's kind of root 3 g upon 8. Okay, so that's it. These are the answers. Thank you.